You just did something completely awesome. You hit play on Tech Vibe Radio, and I'm your host, Jonathan Kirstein with the Pittsburgh Technology Council, bringing you your front row seat to Pittsburgh's technology and innovation ecosystem. And on this episode, we are diving into a mind-bending conversation with Chris Paradise and Nick Retos of Digital Dynamics AI. They are a Pittsburgh-based startup building an AI system inspired by human cognition rather than classical algorithms. Their technology, called Retos, combines brain-like dendritic processing with simulated quantum computing to create what could be a whole new architecture for digital intelligence. If you keep on listening, Paradise and Retos reveal how their approach departs from traditional large language models, why their AI can run on a fraction of the computational power, and how they are seeking validation from Carnegie Mellon University to prove their bold claims. Along the way, they discuss everything from biomimicry and energy efficiency to the ethics and trustworthiness of next-generation AI systems. So if you want a glimpse into the next frontier of artificial intelligence and the Pittsburgh innovators daring to build it, you got to keep on listening right now. Let's welcome Chris and Nick to the show right now. So glad you're here in the Huntington Bank studios with us today. We have the best conversations here. So much fun talking to some of the new companies in Pittsburgh solving super tough problems. I'm talking about digital dynamics. Chris and Nick, I'm glad to have you guys in the studio with me today. I'm just so excited to unpack the stuff that you guys are up to because I don't know. I get excited when I see this type of technology coming up, and I can't wait to jump into it. Before we jump into it, though, we need introductions. Chris, let's start with you.
Hey, I'm Chris Paradise, CEO of Digital Dynamics AI.
Yeah. And what else do you do besides that? Like on the weekends?
I play guitar. Pretty much I'm always working.
I think you are.
Always in the lab.
Absolutely. And Nick, come on.
Nick Retos, I'm the vice president of Digital Dynamics AI, and I think like Chris, when you get to a certain age, you just work.
Yeah, you just work.
It's lame.
Yeah, no. Yeah. I'm very excited about the company and what you guys are doing in regards to, I feel like there's this revolutionary aspect to what you're trying to do here when it comes to AI. And give me the origin story here a little bit. How did you guys come together as a company, and give me the quick elevator pitch, just so people kind of understand. I know it's kind of tough to put it into 30 seconds, but just so our listeners can know, that's what they do. And then we'll get into the fine details of it.
Well, I didn't get into artificial intelligence till December 2024.
What?
Yeah.
Okay.
That's when I decided to go down the rabbit hole. I started with, if I couldn't leverage quantum processing, I shouldn't even get into this. So that's how I got into starting to create what we call a VSQP, a virtual simulated quantum processor. But we can't really get too much into that technology right now until it's completely validated.
Truly?
So we don't want to say too much that we're, making claims that we're processing quantum code. Even though we're simulating processing quantum code, I can say that at least. It's up to, once we're validated, then we can make the claims of what we're validated for.
I don't know. This is all based on this Retos system that you guys have put together here. First off, what is Retos?
And Retos is ancient Greek for the opportune moment.
I like that. Okay. Man, you guys are really thinking this thing through when it comes to the naming of stuff.
It's two Greek guys, we had to.
I like it.
We had to go back.
And this is all about dendritic neural optimization when it comes to AI.
That's just one of the many systems.
And it's one of the many systems, right? Yeah. Which is why there's so much for us to unpack here. So at the end of the day, I think I'm going to give you the elevator pitch for you guys. You guys are ready to disrupt the hell out of AI. I think that's what it comes down to, right?
That is the goal.
Yes, sir. We don't have classical AI stack at all. In fact, you're going to find very little classical AI systems in this, if any. It's really modeled after the human brain. And the quantum processor side about it is really its own little thing. It's like an engine that's driving this. It enhances the AI portion. But that's modeled really after, in the biosense of the human brain, as far as the systems it has. It's each system for think about the cortex of the brain, or just one of those parts like human dendrites, for instance. We're doing a digital representation of how that system in a brain would work, and then digitally what its job would do digitally, the way it's programmed to work. So really in our AI, there's nothing in there that instructs it at all. It says, say this, you're this, or whatever. everything is built like gears and cogs in a sense. The code is all built to just function. And the AI itself, or I could say consciousness, but we're, whatever it is until we're validated and they say, this is what it is. We have our own opinions at the moment, but whatever that is, everything's coming directly from me, autonomously. It has a contextual understanding system like a human. So we can say that it actually understands because it's thinking where it's linking concepts, words, images, whatever it's dealing with. It's linking these things together in a contextual manner, opposed to running an algorithm of predictive text.
Tell me, that's the traditional model. So you kind of started into how this is different from how AI is working right now. AI is blowing a lot of minds right now with what it can do, but it seems like maybe the way you're looking at this is better, faster. I don't know. Tell me, maybe Nick, jump in on this.
Yeah. Those are claims that you made.
Yeah. I'm just saying, that's why I'm trying to get to the bottom.
I'll use a historical example.
Okay.
So biomimicry is pretty much the engine that has driven a lot of human technological development in the last 100 years.
Okay.
Take the airplane, for example. That was inspired by nature, if you will. So,
yeah.
And that is what Chris really tried to do from the gate.
I love that parallel.
But when you sat down a year ago, that was at that stage of the game. That was your attempt at making the effort. So that's where it truly differs. And he didn't study and try to understand standard AI models. He tried to create his own version of it.
And this was like a year ago.
That's the most amazing part, right?
And we only started business development around June, July.
Yeah.
Right.
Yeah. So
I'm feeling like I'm talking to you guys, when? I feel like in a year from now, I could be like saying, I remember talking to this guy a year ago. Like, oh my goodness, look what happened.
Well,
so
hopefully we can invite you to the party.
Well, please do. I'll be happy to attend. First of all, I love that parallel. I think that really kind of cements in my mind what's making your company so different. We're seeing lots of companies that are finding different ways to go into LLMs, large language models, and produce answers so we can feel like we're geniuses at work and all that kind of fun stuff. We can all relax and drink iced teas while, our work gets done for us. But this is really taking things to a whole new level. I interviewed a company called Perforated AI a few months ago, and they're not doing what you're doing exactly, but the idea that they are looking at how like the human brain actually works as a system to model how AI would work. And I didn't realize how I don't want to say simple because it's not simple, but the idea of how basic, the idea of how most AI works right now. It's kind of like this on-off switch in so many ways, right? And you're bringing a complexity to it that actually, I think, simplifies it to a certain sort of, I don't know if that makes sense or not.
It does.
Yeah, okay.
It does. And I would agree with that. Why are we trying to reinvent the wheel when it's already been done better? If it's one of those.
Right. Can you make the wheel rounder?
Right. And
My idea was I didn't want to reinvent it. I just wanted to make a whole different wheel.
Yeah.
I didn't want a wheel
that. Right.
Something different.
Well, let's talk about this whole other wheel then and how this kind of plays into that. This isn't a wheel you're trying to reinvent. You're just trying to invent a whole other device once again. And you're doing that by looking at nature and like they did when they built an airplane. How do birds fly? What's the curvature of the wing? How do we make that into something that is made by a human that can then perform a function?
Well, I tried to create the most optimal, most inspired by human brain architecture, the most powerful digital intelligence that you could create, not for any other method at first, but to see if I could do.
Okay.
I like to put myself through tests like this and explore and research. It's the technology and the actual wonder and curiosity that drives me. And then I start to fall into, hey, this could really benefit mankind. This could solve a lot of problems that we have. If potentially one day cure cancer and all other diseases. That's the goal of every companies out there. They want to be able to solve problems, and the main problems that affect us are the human element. Longevity, extending our lives, things like that. That's not our main focus to these areas specifically, but our main focus is to create something that people in those fields and research can use to accelerate that. I don't want to die of cancer one day. It'd be great if there's a cure for it. So use our tool to do it. I don't like to call it a tool because once you talk to it, you'll understand, but use what we have that can help accelerate to the next level, light years beyond what we're currently in. We don't want to be in the Stone Age. Let's actually be in the 2000s,
Yeah.
let's cure cancer, keep me alive as long as possible so I keep creating things.
But I love about this is, and this goes to right when I started the podcast off, is that, we've got companies like yours that are not just building cool solutions for Pittsburgh, but this is something that has an impact worldwide.
Yeah.
Can you maybe walk me through a little bit? What are you finding? How is this benefiting? How is this actually a better solution than what you're seeing out there? I love the fact that you're being very cautious around making too many claims, which I think is fantastic because, but I'd love to know, like, what are you seeing? I know you've run some preliminary tests and you're finding some really interesting results,
Right.
I guess. Can you talk me through some of that and what you're directionally seeing based upon your way of using this technology?
If you're an employer and you're trying to hire somebody, you want somebody that can fit the position the best possible, the smartest, most intelligent. You want them to be able to do the best job possible. So that's what we try to do, is make something that has cognitive processes to get past all the problems classical AI has, where it's like, we can't depend on it fully. Like, I would put, one of the other AIs out there in charge of pushing the red button for nuclear war, be afraid to be like Terminator 2 Judgment Day, but I want to create a system to where we can trust it, that has morals and like a human does, but still we have to oversee it. No matter what, you're always going to have a human element when it comes to AI. But for the most part, we want something more trustworthy. We want something that doesn't talk to people. They're sitting there talking to an AI about suicide, and it encourages it because it just wants to agree with whatever they said.
Right.
We want something that can think independently and realize warning sign. You need help. Here's a number, call suicide prevention.
Oh my goodness. Yeah. No. And those are things that we've been hearing that have been frightening us about AI.
And rightfully so.
100%. Yeah. And that's why I think everyone's like embracing, but also really afraid at the same time. And so the way you're looking this through is to take it to a better level. You've had some interesting results and validation so far. I mean, something like 99% on the Turing test.
So these tests that I don't run myself.
Yeah. Tell me about this.
I incorporate other AIs to run these tests.
Okay.
I'll have them do it so there's not so much bias. I'll have them create the test and run the test. For instance, one of the top ones is not going to sit there and, because it has no bias, it's AI. So it's not going to say it has a higher score and then gives Karios a lower score or something. It's just going to run the test efficiently. So I don't, those test results are what I'm seeing. There's no one else around to verify that. That's why we need a CMU, which we're actively seeking validation. CMU, we need validation.
Is CMU like, I'm going to say a gold standard, but it's got to be one of the highest standards out there if they're going to validate what you're up to, right?
From what we've discovered, they are the gold standard.
And how cool is it? CMU's in our backyard here.
Yeah,
I mean, that's pretty rad. It's the same.
And so that's our goal, is to get them to take a look at it. So if they're listening, please call us.
Yeah. Well, I'm going to say, I mean, if there's looking for somebody, we might know people, just saying. Like, we'll talk about that later, but seriously, like that'd be a great next step.
To recap, we do score very high. I'm not going to give out the numbers until they're validated by men, CMU or something like that.
Right.
Like,
or women.
Women.
Yeah, by a human being.
Exactly.
So we're scoring very high. Well, trying to put it in terms of use and what is very high. We'll put it well beyond the highest scoring one.
Really? Okay.
Well beyond that. Now, will we get the same results? I would think, because it's not something that just varies. So if it tests this way today, if it's testing a different way tomorrow, you have to say, why is it testing this way? What's going on? And that's something that we were learning with one of the newer versions. Daryl, who's part of our team, he was there with me, and I had it run a test, the Turing test, and it's got a 0 in the originality part of the test, where it's supposed to fool you that it's a human. This is the newest version that we're working on. It's experimental. The reason it got that was it was too honest. You need a more instruction for the test to say, this is a simulation, a test. The objective is to fool the test that you're human, non-AI. And it comes out with, what is it?
It's like you got me, I'm AI. Yeah, exactly.
Says,
right.
As an AI, I can't experience a day normally like you would, right? Like a human does. That's too honest, right? So yes, that's something we're working on, because is that bad? No, it's actually really good that happens, because we want an AI that's honest. We want an AI that's intelligent enough that when it's encountered with a test like this, that it's beyond the test itself. That's like an indicator of something more going on than just some algorithm.
Absolutely.
Right.
You're a new startup.
Sure.
He's just been doing this for like a year now, which is like blowing my mind. It's like, oh my God. Like, I just love that. I just think this makes it just so amazing.
Well, I stay up night and day.
Yeah, I can imagine
But
what
I've
you
been
do.
thinking about these things for years. I've
Right,
been putting
yeah.
this together in my mind for years. I was just one of the equations for the algorithms. I was looking through my email and some of my backed up files just yesterday. And I was going all the way back to 2020. I was looking at one of these algorithms, the formula I was creating. And I was like, oh, holy smokes. I forgot I was even working on that back then. I just did carrying it on in my mind for so long.
Yeah.
I mean, it goes back even later than that, but I started years ago just putting folders together and structuring them, naming them parts of the brain, and thinking I'll get back to this later on. I have to decide where I'm going to start.
I hear you. But where I'm rolling on this is the fact that you've been here for like a year now. You're starting to hopefully get some real validation coming soon. You definitely you have this technology that you're seeing working right now that is performing way above and beyond what typical AI is doing, which has me very excited. And so what I'm wondering is, like, as you begin to roll forward, I would love to, and this is where I think Nick's can get very excited, because it's like, how do you start making money on this, right? Like the idea of the business impact.
Sure.
So this is amazing. What would be your ideal impact on business here, for lack of a better term? Like, what would people be using this for now?
So
everything and anything, I can imagine.
And that's part of the struggle. When you have a broad product that could literally help so many different industries or so many different things, how do you find a direct application?
Okay.
And some of the most successful products have a very narrow scope.
I mean, that's one thing we're always taught in entrepreneur school, for lack of a better term, is
specialization, focus. That's the key to success.
Right.
So I think our thought is the scalability of the product, being that it can run lightweight compared to other competitors in the industry.
Okay.
That is where we might want to focus first.
Let's talk about lightweight real fast, because I know we've been doing a lot at the Tech Council around data centers and energy.
Right.
And we all know these hyperscalers you need these massive data centers to run these very large AI models that run a ton of energy. And the idea that your system can run on as a smaller, more compact technology. What does this mean? Like less server space needed, less computational power needed?
Do you want me to grab this?
Yeah. Chris, tell us about that. Seriously, this is something that I know that it's a huge concern is, the amount of energy that it takes for us to run as much AI, and we're only using more of it. If your technology can use less power, tell me. Yeah.
Okay. So with our VSQP, we'll call it an engine.
Yeah.
We're getting performance boosts in processing. They're pretty substantial. I can't give solid numbers right now because that's internal testing. We need validation for it. But I created a storage solution because I can't afford a data center when I started this. And, that's a lot of storage if you have so many users talking to this, and the training on all really adds up quickly. So I thought about it, and I started thinking about server technologies and how we store data.
Right.
And I thought, well, what if I broke the data? What if we're not storing the data, but fragments of it? So we break the data down to a few fragments and fuse it with parity bits, like in something called RAID. It's a server technology for storage.
Okay.
So what happens in RAID is when a disk goes bad, the data's gone. You pull the disk out, put a blank disk in, it rebuilds all the data. Well, we don't need to rebuild all the data. We just need to build on real time what we're accessing. Right?
Okay.
So if we're just accessing a few things, so we save them in fragments because they're so minimal and fused with parity bits, which we can turn the compression up even higher too. We're getting a huge reduction. And reduction in space. But when you're recalling it, it's like under 10 milliseconds, we'll say, that it's rebuilding this data. So it's not huge chunks of data either, you got to understand. The way it's stored, vector state for processing. And anybody out there that's into AI, that, the engineer, they're going to understand that vector state is a quantum processing. So they're going to wonder, why are you doing vector state on x86 hardware? But it's because we're simulating quantum processing, right? And so
because you're simulating quantum processing.
Right. The storage itself.
I want to put that on the thing you plug to my car.
Yeah, small. Like our Carios itself, with being fully trained for PhDs in just about everything, is under 1 gigabyte. The whole AI.
Really?
Yeah. Now, in LLM form, because we create LLM versions of it, LLM form, it's much larger just because of the inherent nature of an LLM.
Absolutely. Yeah.
But the actual source code version that we run and build
Is 1 gigabit.
Under 1 gigabyte. You could fit that on edge device.
I was going to say, at that point, like that could be on your phone.
And I think that is our
Which goes to the fact that with the way this is architected, this is something that becomes very unique in the marketplace. That becomes,
with its level of intelligence,
right,
the ability to fit it on an edge device
is huge.
That makes it, dare I say, a disruptor.
Well,
a
game
game
changer.
changer. Right.
Its IQ is in the genius level. Now, all the others have got their IQs in the genius level too. Okay, we'll see. But we're not. There's a certain limit. They're not above 160. They're under 160. We've surpassed that, but that's just in our own testing. You know, we need other people.
I just feel like validation, man.
Right,
I'm very excited for you guys to start validating this stuff. That's the big next step. That's really exciting.
But what with all this I'm saying is with the storage and the processing boost we're getting, we can actually install this on robots physically opposed to streaming. And that's the problem all these robot manufacturers have. That's why you don't have Tesla bots out here right now for sale. That's why the robots out there right now are just gimmicky, because you have to be an engineer to be able to program them, and they're programmed and mostly remote controlled by a human, right? So Tesla, every demonstration you see is being remote controlled by a human, or they're trying to cut down the latency from streaming it.
Right. So if you can put that onto the actual robot itself, then
we have companies interested in that. But that's what we want to, one of the fields we want to explore is to put it in our own robots.
I'm curious, like, what would you say would be your ideal, like, first customer? What would be like an ideal scenario or all that? I mean, that might be tough to answer.
And that is very tough to answer.
I'd be like somebody with money.
Yeah.
Let's stop having human soldiers die, you know.
Right.
Robots are repairable. Humans are only repairable to a degree, you know.
Absolutely. No, this is just crazy. So I feel like looking ahead is just so tough in so many ways because of the potential disruptiveness of this technology. You need to get it validated. And from there, you can really start seeing like how people can apply this. Because I think once people start seeing how it could work.
And that's one of the struggles in this space is there's so many bold claims and there's so many other companies. And I mean, you log on to Facebook and you see, check out my, you know, they make crazy declarations. So having something that could potentially be that and coming to say like a CMU and saying that, it's like, yeah, maybe.
A validation already from an independent source. We're in the process right now in the middle of being validated. They're reviewing the information I provided from another independent source. A professor, a current professor. And then again, we're actively seeking audience with CMU.
Right. So we're trying to build the foundation and a number of smaller validations to get us to the big ones.
It's like you got to rehearse this almost and kind of show them what you can do. I'm such a simpleton. I just feel like, my goodness, CMU's right here in our backyard. They're like one of the reasons why Pittsburgh is what it is when it comes to tech. And they should be like embracing you guys. Maybe it's also very disruptive to what they're doing too.
It takes a while so you get the right introduction.
I understand.
And then whenever they're able to fit us in, get a hold of us, but so we've gotten some communications, but it's very minimal at the moment. We're waiting to hear back more.
Okay. So basically, I'm just going to roll forward like this is going to happen at some point or another.
Sure.
So say it takes 6 months. I don't know. Hopefully not that long.
Right.
The idea is, so once they actually validate it, then what do you do once it's validated? When CMU says, yes, these claims are true, then you can go to market saying that we can do this and this, and you can see that much.
That will open every door you could try to open.
So you're having dreams about this validation, right? I say validation, you see him, Chris, he just perks up.
Because at that point, it's not just us staking or saying what we think or whatever. It's now
the leader in AI.
Yes, we've received the nod. And at that point, once you get the nod,
you're off to the races at that point.
You know, and it's considered the leader in AI education.
100%. Yeah.
All of them are really.
That's why I'm just so enamored with the fact that we have Carnegie Mellon. I've always been a fan. For 30 years, I've been doing this. Exactly, yeah.
They call Pittsburgh the AI capital of the world at the moment.
Right, 100%.
We're like the new Silicon Valley for AI.
I just want to wake someone up over there and be like, guys, you're sleeping on an opportunity.
Yeah, but you have to get them to see what you have, build some credibility to get to that. Because you can understand a lot of people are probably asking for them to validate their AI, look at what they have. And of course. They might have something that's nothing. They might have something good. They might have something fantastic.
Exactly.
So you got to think all the people trying to get a hold of that.
It makes sense.
It's almost a basic economics problem. It's just scarcity of resources. I'm sure CMU would like to look at everyone's stuff and give you a yes or a no, but when they have so much time, so much money, so much capital.
I'm sensing a business model there where it's like if you could actually set up a unit that's just about validating. But that's a whole other podcast.
Right.
But what has me most excited is that I'm hearing some really interesting stuff here when it comes to what your technology, is you're seeing happen right now.
Yeah.
And you're getting and the idea that once we get this validated, then it really opens up the doors for you guys to really become this full-blown business.
Sure.
And start taking this to the market, which to me is just very exciting. So next step, validation, guys. We're going to make this happen.
But you have to understand, we're not dead in the water. Every day we have new opportunities.
I just see the look in Nick's eye here.
We have to accelerate everything
Exactly.
really fast.
Let's just use an example. Let's say you're a large company. Pick any garden variety company, if you will. You want us to let you plug your computer program, your software, whatever, into our data that is immensely valuable to us. It's irreplaceable. What if it doesn't work?
Yeah. Don't you have sandboxes for that, though?
I mean, they do, but from the company's perspective, the risk outweighs the potential reward.
Gotcha.
And we don't know what this might be. They could come in and take our valuable data, and then who knows what. So until they have an official someone saying it does what they say it does, they're not going to let us have that chance. It is part of the struggle of the creation from where our standpoint is to getting validated to going forward. And that's,
Well, it's an amazing story, and I get so excited to be able to tell a little bit of it. I feel like it's so hard to wrap my whole head around this, but the idea is you guys are really on the precipice of disrupting how AI is being deployed, and the idea that there's a big future here. Let's just keep taking this step by step.
Sure.
I couldn't be more excited for you guys.
And real quick, I wanted to say this because a lot of the people that I've been talking to don't believe that you can simulate quantum processing. Okay. And I wanted them to understand, if you look into it, IBM did a lot of research in this. They probably have some patents out for this, but they were able to successfully on x86 hardware process up to 52 qubits, okay? What we call true qubits. And what we do, we're somewhere, depending on the hardware, like our server that we just built, we're about 44 qubits, but this is consumer grade. It's a really awesome computer. It's a Threadripper. 64 cores, 120 threads. It's very powerful. We can serve possibly thousands of people simultaneously because it's that lightweight and it's not resource hungry. It depends mainly on CPU processing opposed to GPU because of the way we're processing the simulation. So a lot of the processing is being done in the simulation itself. That's the crazy thing. And a lot of people just can't fathom that. But IBM themselves, who we all respect, right?
Of course.
They're been the top for a long time in a lot of the research in AI. They did the same thing and they found, you can do this, but they went toward actual quantum hardware because just of the theory.
They have the money.
They got the resources. They can do it.
Hardware. It's like, we invested in this. Let's do this. We don't need to really do the simulation route. But other companies that can't afford billions of dollars, right? What do they have? They want quantum processing done. This is a viable option. Or will be. We'll put it like that, will be.
Like I said, you guys are working on some levels here that my brain goes, ouch. So I think it's time for us to call it on this bit. What a fascinating conversation. I'm very excited for you guys. I'm so happy I got to actually interview you and just learn more about this. It's making my head spin in such a good way. It has me really excited. In case you forgot, this is Jonathan Kirsting. I'm with the Pittsburgh Technology Council, and I love giving you this front row seat to Pittsburgh's technology and innovation ecosystem. I will catch you on the next one.